Okay, we've asked the question, why are we doing this? What good does this do us? What application does it have to differential equations? And we've now determined that if we know the Laplace transform of a function f of t, we have a way of writing the Laplace transform for f prime of t. And this is going to allow us right now to go ahead and transform a simple differential equation to get the flavor of the process before we develop a lot more detail. So we have enough information at this point to transform this very simple basic equation. Of course, we can easily solve this equation, use integrating factor e to the negative 2t, and so forth. Simple non-homogeneous first order equation. But remember, it took a little while to understand how that integrating factor worked. Matter of fact, at this point of the course, that's been a little while, you might have forgotten how that worked. But you remember that it's not the most difficult process, but it's not by any means quite trivial. Okay, so let's Laplace transform our equation. Now, one thing that we're going to need, the Laplace transform is linear. I haven't proved that, but it's a very almost trivial consequence of the fact that this integral is linear. If we were to integrate a function f plus g times e to the negative st, that would be the function f multiplied by e to the negative st integrated plus the integral of g of t times e to the negative st. And if we've got constants, the constants just come out. Everything is nice and linear. So the linearity properties of the integral implies the linearity property of the Laplace transform. This means that to Laplace transform the equation, all we have to do is Laplace transform y prime minus 2 times the Laplace transform of y equals the Laplace transform of e to the 3t. Nothing to it. Of course, you still don't understand where this is heading. Or maybe you do. Maybe you've looked. Maybe you've seen ahead already. Okay. Well, anyhow, this Laplace transform of y prime. Now let's go ahead and put some kind of an initial condition here. Let's say y of 0 equals y0, and we could put a different initial condition on it. That's not really a problem, but easiest if we use initial condition at 0. Okay, now the Laplace transform of y prime, what's that? Well, we just showed that the Laplace transform of the derivative is s times the Laplace transform of the function itself minus that function evaluated at 0. It's not much of an extension to say, okay, the Laplace transform of y prime is therefore s times the Laplace transform of y minus y of 0. So this gives us this. And then that's minus 2 times the Laplace transform of y. And that equals what? That equals the Laplace transform of e to the 3t. Well, we don't have to remember too far back to see. Matter of fact, that was our first example. I didn't really even think of that when I wrote that down there. It was just kind of a natural function to choose. We've already seen that the Laplace transform of e to the 3t is 1 over s minus 3. And that, of course, comes from this more general formula for the Laplace transform. And we'd better write down that s is greater than 3. So now we have, might not look like it to you, but this is just an algebraic equation. The only unknown in this equation, s is just a parameter. The only unknown in this equation is our unknown. So let's solve for the Laplace transform of y. Easy enough to do. Let's add the y naught over to this side, and y of 0 is y naught, so I'm going to write it that way. So the right-hand side is going to become 1 over s minus 3 plus y naught. The left-hand side is just s minus 2 times the Laplace transform of y. So, what's the Laplace transform of y? It's just 1 over s minus 3 times s minus 2 plus y naught over s minus 2. Now we're going to have to do just a little work. We're going to have to separate this into partial fractions is what we're going to have to do. But that's pretty easy for this expression. And while it might sometimes be tedious, it's never really difficult. Easy to mess up, but not particularly difficult. This is just y naught times 1 over s minus 2. If the Laplace transform includes y naught over s minus 2, 1 over s minus 2 would be the Laplace transform of e to the 2t. This tells us there's going to be some kind of an e to the 2t function in the solution. Let's see what comes out of this.